this whole section that I highlighted. Based on the following product information, insert product information here. Question, that's going to be my question that I asked originally. What features does Lickety Split have and what's the pricing? And then I'm going to provide this really critical piece of information. Answer only based on the provided information. If the information doesn't answer the question, say so. This is your guard against hallucination. This is giving the model permission to tell you, I don't know, rather than having it hallucinate something. So that's what we're going to do. We're going to take this system prompt, we're going to pass it in, your helpful assistant, answer based only on the provided context. And then we're going to take the prompt that the user types in and we're going to pass it through this function to go do the searching. And if it finds search results, bake those right into the prompt. So this time I'm going to debug this so we can sort of see step by step. So right now, this is my question. That's all there is to it. But now I get back this augmented prompt, and I'll print this out in a second, but you can already see that it says based on this following product information, and here it goes. It's done our product search and it's found Lickety Split, which it should have based on the name, and it's provided all that information we had in our product database into the prompt. Okay, so if I turn this loose now, let's look at the augmented prompt. So now, instead of just my original, this is what I sent in. So this was maybe what I typed in the chat interface, right? This entire thing is what actually got sent to the LLM. So the prompt has been augmented with this very specific product information. So now if I look at the results that I get back, I get a just nice, concise breakdown of the features and the pricing, which is the answer to my question. But now this is topical, it's correct, and it's got accurate information in it. Any questions or feedback before I move on to the next section? Because that's pretty heavy, that whole section. All right. So then let's look at the idea of enhancing this a little bit with semantic search. And this is another one of those things. It takes a while to wrap your head around this, and you're not going to be an expert, but I kind of want to give you a little bit of the flavor of how this works. To get an embedding, this is actually an API call that gets made to a model, in this case, an OpenAI model. And it's this model, the text embedding 3 small. These are models that are specifically designed to turn a chunk of text into a big vector of numbers that I can compare. And when I compare them, it's going to tell me if they're similar. Not that there's an exact match, but that it's just going to tell me how similar they are. Oh, I played instead of debug. Oh, sorry. This is just, so that, I was a little confused on how this worked. That actually just added variables or added embeddings into our fake product database. So what does that actually mean? This is the cell I want to debug. Let's go look at our fake product database in the debugger here. Here's my list of products, the 4 products that I hard-coded up there. Let's look at Lickety Split Pro now. So these are the things that I hard-coded in, the name, description, features, keyword, and price. But here's this embedding. So what I did is I took the product name and the product description, and I sent that off to OpenAI, and I said, give me an embedding for this product name and product description. And what does it send back? It sends back an array that's 1,536 elements long, and it's full of floating point numbers. So it's just a really big, long vector of floating point numbers. So not something that they're completely opaque to me. I have no idea what any of this means. Only the algorithms understand this. But I've retrieved one of these for each one of the products, one of these big array of numbers. So the question is now, if I search for this, is it going to find something? So let's see what our query is here. Our query was the words high-speed data access. So what happens when you do RAG with semantic search is you take that query, you reach out to OpenAI and you say, well, give me an embedding for the words high-speed data access. And now I'm going to take that embedding and I'm going to compare it to all these ones that I have stored for my product. And so this is the part that normally you never see this. You would never actually do this in practice. You would use some product called a vector store to do this for you. But I did this intentionally just to show you, again, what's going on under the hood. You look at this, this is just math. This is pure linear algebra. There's no magic going on here. This is a property of these embedding vectors that when we do this cosine similarity, it's just doing some dot product and some multiplication here. It's just doing linear algebra on these two arrays of numbers. And the bigger this number, the more similar the semantics are of the wording in there. So this is just a new way to do a search that can find things that are a little more subtle than an exact keyword match. That's the story behind embeddings. If I take this breakpoint out and I run it, this is just going to compare. Oops, that's why it's not finishing, because frozen at a breakpoint. So let's look at the difference in here. And I thought this first one was especially interesting. High-speed data access. When I do a keyword search, Diggity Dog Analytics is the #1 result. Lickety Split is the #3 result. When I do a semantic search, it's exactly the opposite. If you look down here, they go reverse. So the semantic search thought Lickety Split Pro was a really good choice. Keyword search says, I found exact matches with Diggity Dog Analytics. Some of these others weren't as dramatic. You know, here, the #1 result was the same with both algorithms. Same thing here, same thing there. So that's just to say this is the trickiest part of trying to implement RAG on your own, is that trying to tune this search can be very difficult. And the final thing I'll leave here is that most modern implementations do some sort of a hybrid search where they'll actually do both the keyword search and the semantic search. And then they use a little algorithm to try and combine the rank. So in this case, the rank was 3 for keyword search, but rank was 1 for the semantic search. It would come up with a final score, and then it would use the combination of those two ranks to figure out what's the quote best result. And that's a hybrid search. So this was a final solution, just running this prompt. What's the best solution for high performance data caching with Redis capability? Okay, so this is a much more complicated inquiry into my product database. But both models came up with the answer. Lickety Split Pro is the right solution here. And then it goes on to describe why based on the features that were in the features list. So complicated subject, but I think an important one to at least have some exposure to understand what RAG is. And I would encourage you, if you're interested, to spend some time playing with that Python notebook on your own. Because it can be a really interesting exercise and give you some great understanding of how that technique works. Any other questions or feedback on that before we jump back into slides? All right. So we're ready for another hands-on exercise. I know a couple of you were working on getting the code space up and running over the lunch break. So hopefully a few more of you have gotten into a position to be able to try some of this out directly. Sorry, just trying to keep track of my schedule here. So we're going to move on to implementing some additional functions here. And in this case, we're going to try and do multiple different validation functions. So there are some sample functions or sample prompts in here. I'd like you to try some of these out and use the additional knowledge that you've got in these prompting now and see how you can change these prompts to try and get some different results this time. If you're, I know there was a couple that were trying to get Claude Code up and running. This would be a great opportunity to try Claude Code out, or you could use GitHub Copilot as well. All right, so this one, we've got a little experience here. Let's just take about 15 minutes on this one. I'm going to step away from keyboard for just a short second, and then I will be back and can join for a demo as well.
Yeah, just a reminder, those that want to go work independently, you can head over to one of the breakout rooms. When Ryan gets back, he'll start the demo here, so that'll reserve on the recording so you can come back later and look at it. So sit tight, he'll be right back.
Okay, thank you for your patience. So is there anybody in the class that's anxious now to try and go and build your own retrieval augmented generation solution? You should be. It's fun.
Yeah, I'd be interested in that.
Good. Yeah, talk to us after. It's probably one of the first things that comes to mind when people start thinking about how to implement, how to leverage AI inside their own products or even inside their own marketing website, is the idea of a chatbot that has some information, internal proprietary information, or very specific product information. So that's part of the reason to bringing that up. All right, so I think I done most of the demos GitHub Copilot. So let's do this next one with Claude and see how that experience is a little different. So we've got potential or example tests in here as well. Go. And right now these are all skipped. I just marked them as skipped until we actually implement the function. So it's a little easier to tell what we've worked on. And this one I thought was a little earlier, so I may feel a little bit out of sync because I thought this one was in a different order, but I think it's useful to take a look. We're starting on again with just a 0-shot prompt. Really kind of a poor prompt. So what's missing out of this prompt? Who wants to jump in and scold me for being very poor with my prompting? Well, there's really nothing. The only thing in the clear framework in here is the action. Write a function to validate an email. Done. I've created a function. Does it pass any of my tests? Not a single one. All right, so that's, it has a very different idea of what constitutes valid, apparently, than the original tests. So now let's add some requirements in. Get a kick out of the Claudeisms that it occasionally will pick words that are somewhat related to what you're doing here, but it must have a whole database full of ridiculous words to have you watch. Take this email as an email string. Now we're prescribing a particular return. So we looked at our original implementation. Did find part of this. Now it's starting to pass a few of our tests as we get more and more specific. So now let's add some of these critical examples. So this is really going to let it hone in on what's happening much closer. We've gotten a little bit tighter in here with the requirements, and we've added quite a few specific edge case examples. And then a couple of very basic ones that are legitimate. This is the kind of refinement process that you would go through with your prompts as you're learning. And then eventually you'll get to the point where you'll just start to write things that are a little closer to this. Even though it may take you 3 times as long to write the prompt, you may spend half the amount of time waiting to get to your final result because it hits it on the first try rather than having to go through 2, 3, 4 iterations. as this thing chews away, the other thing that I'll point out here, you might feel like this one is quite a bit slower than when we saw the same thing in GitHub Copilot. And that's a direct result of the model that it's using. If I look in here at what model I'm using, the usage plan, the Claude Max, allows you to use Claude Opus for up to 50% of your usage limit per day. Then it falls back to using Sonnet 4. And so this is currently, because I've done hardly anything today, it's using Opus, which is its top level model. And it's also by far its slowest model. And so while I may get better results, it's going to end up taking a long time. So more often than not, I use, oh, and that's a brand new feature that I have never seen. They must have just released it today, the plan mode. And that makes a lot of sense. Plan mode is a thing in Claude code that allows you to disable tool use. So it will only go back and forth with you, and it helps to kind of form a plan of attack on a much more complicated problem. And then you can turn it loose to actually make edits. But I could put this into Sonnet mode now, and it will speed up a fair amount because it's using the smaller model. And so now there you can see clear evidence that having a really well-structured prompt, that was the first time that it was able to pass all of the tests. So it is worth, it feels a little onerous to try and put together prompts like this. But things like the examples, if you have a reasonable requirements document, you can actually use the technique that I did earlier where you ask the model to create a prompt for you and then turn around and feed that prompt right back into there to get your code. And so that is a technique that I think is useful as you're learning in this code. This is a process that we use internally on our team, and we've used it very successfully. You actually go through a documentation phase, a planning phase, an implementation planning phase, and then a prompting phase. And the idea is you use chat interface to come up with your list of requirements for a particular story or a particular feature. And you just sort of go back and forth like you would on chatgpt.com until you come up with a reasonable requirements document, and you save that as a markdown. Then you go through the second phase where you just ask the model, look at this requirements document and help me build an implementation plan. And you break that down as a second markdown document. That implementation plan may be a step-by-step guide of something that's way more complex than you're going to ever generate in one go. This might be something that you might generate over the period of several days. But you use that file as a way to maintain some memory. And then you tackle each step, and then you feed in your actual code generation prompts and say, look at this implementation plan, execute step number 1, and then provide a direct prompt on what you want to generate there. And you just mark the things that are done as you go. And then you can turn that into an iterative process where you can tackle a much bigger, something that's maybe feature level that would have taken several sprints earlier. You can usually accomplish that in a single sprint now by using that breakdown method. And so it's sort of like the same idea of chain of thought, but just escalated to a much higher level. So some production level considerations if you're going to actually build a RAG system. Some of the things to think about, RAG takes a little longer. So there's a certain amount of time involved in doing that search, generating the prompt, sending it in. There are other techniques out there that will actually make multiple calls to the LLM. One will send, and you'll see this happen in agents like GitHub Copilot and in Claude Code. It'll actually take your words, send it to the model, and say, turn this into an effective search query. And it uses the natural language processing of the model to take your input and turn it into something that it thinks is a really good search query. Then it'll do the search, augment the prompt, and actually send that back a second time. All of those things add time. So that's finding the right balance about how much time users will allow before they get frustrated and just quit using it. Other problems with RAG is storage. Not so bad with my 4-product database. You can store 4 of those vectors. But if you do have something like a product base that has hundreds of thousands or even millions of items, then suddenly just storing the embeddings, managing those embeddings, generating them, keeping them up to date becomes quite the exercise. Again, accuracy is very tough. That's the hardest part with RAG. So you do have to spend quite a bit of time evaluating the performance of that system, record everything, extensive amount of auditing of here's the query that came in, here's what we found, and then ideally capturing feedback from the end user. Did this produce what you expected? So if you've ever noticed the little thumbs up, thumbs down and things like GitHub Copilot, that's what they're doing. They're recording the prompts that were sent in, the response came back from the LLM, and then they're capturing their feedback from you as a user as to whether or not that was successful. And then they audit all of that later to determine how to change their prompts to try and get better results. So this was just a quick reference that I added in the slides. It kind of goes over the 4 types of prompting that we've covered now: the 0 shot, the few shot, the chain of thought, and the retrieval augmented. So any questions on any of these topics before we move on?
I have a question, Ryan.
Yes.
Would it be a good time for a break?
Sure. Yeah, let's do a short break. I'm glad at least one person got the Vaultec reference. Thank you.
Looks like before we go, there's a couple questions coming up here, and or they were voting for a break. I think the hands went down. So unless there are questions, we'll move into a 10-minute break, and I'll get this going, and we'll see everybody in 10 minutes. All right, team, welcome back. And I think we're ready to move on to the next topic. And when you're ready, Ryan, take it.
Yeah, I don't know about you, but with the combination of the afternoon lull with all those waves, I was kind of mesmerized. I was ready to take a nap.
I don't know if I should say I'm sorry or you're welcome. We can talk about
Yeah, I
that
think
later.
yeah, I think in hindsight, we should play something energetic in the afternoon. The calming thing should be for the morning.
I'll find if we do decide to do one more break, we'll do the epic awesome timers.
Perfect.
All right. Thank you
So
for the
we've talked a
feedback.
lot. Yeah, we've talked a lot about interactive agents. You know, we've seen them in action now several times with GitHub Copilot and with Claude Code. In interactive assistants, I think that's the one that most people think about first. When they think about coding, a coding agent or a coding AI, they're thinking about an interactive agent. I also wanted to point out that there's a concept of an autonomous agent. And an autonomous agent, like it says, is works all by itself, all on its own. So there's really there's a couple others out there in the fringe, but the most well-known one I think is actually built right into GitHub. So I created a fake issue here that talks about some of the code in this repo. It's pointing at a refactoring demo. So there's some code in there that it's just a simple little API, and it's got a bunch of SQL statements sort of sprinkled throughout the API code. And part of that was to try and refactor that to use a repository pattern, pull all that SQL stuff out and package it nicely. The other thing I wanted to do with this little demo API is say, well, let's add proper validation rules into the input. And so I'm going to try and kind of show off that we probably won't have time to actually see this in action, but I want to introduce the idea here that we're going to actually assign this to Copilot. So when we do this, this is actually going to fire up an autonomous version of GitHub Copilot. It runs all on its own. It's free to use all the tools that it needs to without any human interaction. So GitHub is actually going to pick this up, and you can do this with the command line utility, by the way, too. You can assign Copilot. But this is actually going to run up a container in the cloud. It's going to load this. It's going to clone this repository. And it's, oh, in fact, my watch is buzzing at me right now, telling me that Copilot's been assigned to this issue and it's about to pick it up. So it's going to actually take this GitHub issue as its input prompt. So I'm not going to type anything in. I'm going to consider this to be a well-structured prompt. I have context, I have requirements, I have examples. I have all sorts of additional success criteria, additional requirements. So this is taking all the stuff that we learned about Clear and it's writing it in the form of a GitHub issue. Now GitHub is going to pick this up. It's going to run up a container. It's going to run the GitHub agent inside that container, and it's going to do all of this until eventually it's going to create a pull request. And maybe we'll come back to this right at the end and see if it's completed. It sometimes takes a fair amount of time. Might take half an hour, might take a couple of hours. What this is going to do is it's going to treat the agent as if it were an entry to mid-level programmer. You're going to assign it. If you have something that's well-defined and you have a well-written issue that fulfills all those clear criteria, and it's something that, particularly like this, something where there's a very strong pattern involved, there's a pretty high level of success that I'm going to get a pull request that I'm going to be able to actually just approve. And so believe it or not, I'm going to be able to probably delegate this off to that agent and come back later and just approve the pull request. If I don't approve it on the first try, it works just like a human. It's going to create a pull request. It's going to put comments on it, letting it know what it's done. And if I don't like something, I'm going to do a code review just like I would with a human. And then the GitHub agent is actually going to pick up those comments, treat them as a second prompt, just like when I'm working with the interactive version. I use comments inside this pull request as if they were an additional prompt, and it'll pick it back up, do some additional work, make those changes, and then we can go through this cycle as many times as I want. But that's the concept of an autonomous agent. And in fact, you can simulate this with Claude Code. So let's get into the refactoring demo. And I'm going to add this dangerously skip permissions flag onto Claude. And it means what it says. This is potentially dangerous. I'm okay with doing this here because I'm working inside a dev container. So this dev container is effectively a sandbox. If the AI goes crazy and issues a delete statement for the entire file system, I'll just close this container, open it back up again, and I'm okay. So I'm doing this in a very specific environment where I feel reasonably comfortable that if it goes completely wrong, I'm still in a recoverable position. And I've also specified that it uses the model sonnet because I want this thing to kind of move along a little bit further. Yes, I accept. Go for it. And now I can give it my prompt. And I could have actually, I'll just paste this up here so you can see it. So it's telling it what my problem is if I look in these things. So here's this get call, and you can do, it's doing some SQL building right here inside the handler function for that route. So I'm just telling it my context. This has grown over time, the way things do. We all have good intentions. The database queries are currently mixed in with route handlers, making it difficult to test and maintain. So giving it some requirements, extract these things out into queries, switch the route handlers to use the repositories, use consistent naming conventions, use documents. And now I'm going to turn Claude loose on this. And the thing that's different now is because I've turned off permissions checking, whenever the agent wants to call a tool, it's just going to do it. So I could actually kick this thing off, go have a coffee break, come back in a bit, and then, of course, review what it did. But this is a technique to turn Claude code into something very close to a fully autonomous agent. So this thing will happily chug along as we go on. So the idea of fully autonomous agents is progressing. In fact, the team that I'm working with now is, well, the one guy who's not here is because he's working on a fully autonomous coding agent today. So interactive agents, they're the kind of thing you sit with. You know, they're more like a pair programmer. It's the two of you sitting side by side, whereas the autonomous agent is the junior developer that you throw a piece of work to and you come back later and critique it. All of these agents, you know, I think we've sort of seen this. They all have sort of the same fundamental tools. They do things on the file system. So they can create files, delete files, rename files, move files, read files. They can all do command execution. So almost all of them will run commands like npm. They'll run tests. They can interact directly with Git. Another thing that I did that was kind of an interesting exercise is that you can just explain to your agent that you have the GitHub CLI installed, and it will immediately start calling the GitHub CLI for you. So if you want to use your agent as a way to kind of build your GitHub issues or manage your GitHub issues, all you have to do is let the agent know that you have the GitHub CLI, and it's been trained on plenty of examples of how to use the GitHub CLI. It's very effective at it. And then you can use natural language commands rather than having to remember all the command line. And that's actually true of if you have any popular tool like the Azure CLI tool or any sort of CLI tool to any other platform. As long as it's pretty well known and there were plenty of training examples, the agents will be very effective at issuing those commands on the terminal for you. And they all implement multi-step workflows in one form or another. So that idea of the to-do list in Claude Code, or the ability to do multi-file changes in GitHub Copilot, all of those agents have that. So we've sort of seen this demo, we just did that. There's another one that's kind of worth mentioning, and Dave, you mentioned the one that you use, Kilo Code, is an open source one. They were the first one to kind of use the sub-agent idea, so that's what's really kind of neat about Kilo Code, is that it will act as multiple different personas. It'll work in an architect mode where it doesn't immediately start changing everything underneath you. It allows you to just sort of think through your design process first with that sub-agent, and then it will launch into coding agents. Aider is another one. This is kind of nice because it's open source and it connects to all sorts of different models. So this is really useful if you really want to try out a wide variety of models. So we've really hit prompting both interactively and in things that you might use in production with your own agent through zero-shot prompting, few-shot prompting, chain of thought, and retrieval augmented generation. We've talked through agents, both interactive agents that you sit down and work with like a partner, and now the autonomous agents. And so there's really one last topic that I wanted to be able to put out there for you today. And I think it's one that's really critical to understand because it brings a tremendous amount of value, some potential downside that we'll have to talk through, but really opens up so many opportunities that it's truly, to me, one of the most amazing parts of working with a coding agent. And that's the Model Context Protocol, MCP. This was a protocol that was put forward by Anthropic. They pioneered this idea and it took off like wildfire. Everybody was like, man, that is a really good idea. We should get on board. It's a protocol that makes tool calls exchangeable between different agents. So it's a common way of describing a tool. And so an MCP server can describe a tool. And if you remember back to the very first demo, we described a tool just by giving it a name, giving it a description, and then providing a JSON schema for what its parameters look like. And that was enough information for the LLM to effectively decide whether or not it wanted to call that tool. So now MCP is about a way of connecting other sources that know how to describe tools and then handle the tool call on your behalf. So why does that matter? It means that now you can immediately plug in tools from all sorts of different sources into your agent without having to wait for the company that wrote that agent to implement them for you. And so that's really what I want to jump into now is MCP servers. We're going to talk about how to configure them, how to look for existing MCP tools and how to plug them into the agents that you're using every day. And then the final thing we'll do today is, and this is, if you haven't done any of the hands-on exercises yet, I would encourage you, if you're going to try one, to do this one, because I think not only is it a little more realistic example of providing prompts to build real code, but it's also a great way to understand how MCP works. Of all the things that you might code on your own related to AI, it's most likely going to be an MCP server. And I think you'll see why as we get deeper into this. So you can add MCP servers. Adoption is growing very, very quickly. In fact, almost every coding agent, or maybe every coding agent that I've tried recently, supports MCP servers. A couple notable ones, just to give you some examples of what you can do with this. GitHub just released their own official MCP server. And I think this happened maybe within the last month or two. So you can plug in an MCP server directly into GitHub. So this is sort of like the new official way of the technique I just described, where you can make the GitHub API available to your agent in a first-class way, rather than just kind of the old way of telling it, hey, I've got this on the command line. Another one that I use almost daily is the MongoDB MCP server. And there are servers coming like this from almost every platform now. This is such a useful tool that companies are quickly spinning these up and making them available to you. So if this is one of those things that is changing almost weekly. So if you have a favorite platform that you work with, maybe it's a database, maybe it's a logging, maybe it's an analytics platform, I would check to see if they have an MCP server available. So what's some ways that you can find these things? OpenTools.com is one that I've kind of played with. This is sort of a nice way people have kind of open sourced this and registered a ton of different things. And so it's, again, these things are popping up like crazy. And so they're, Azure has an official one. Almost everybody now has an MCP server. So the last concept that I want to go through is understanding how MCP actually works, because I think that's useful as developers. And you'll see in a minute why it might be worthwhile to implement your own custom MCP server. And the exercise that you'll do, the in-class exercise, shows just how easy that really is to implement. So the first concept is the transport protocol. How do they talk back and forth? How does the agent talk to my MCP server? And this is the one that I think is the most unusual, is that when we talk about a transport protocol or a communication protocol, almost always these days we're talking about HTTP. Maybe we're talking about gPRC and something like that, but more often than not, it's HTTP. So we think of a server, we use the term server, we think of a server sitting in the cloud somewhere that's hosting an HTTP server. It turns out that in the case of MCP servers, the most common MCP server is actually running as a process on your machine, and it's using the standard in and the standard out to communicate with the agent. So it's actually just using the terminal, basically, to pass text back and forth. The MCP spec itself defines three things. It defines tools, which is just like the tools that we've talked about within the internals of an agent. It talks about resources, which are read-only resources. You can think of like documentation files, databases, and then prompts that you can use as reusable templates. Almost nobody implements anything except for the tools. So while these other two ideas are in the specification and they're kind of cool ideas, the reality is that honestly, anybody just implements everything as a tool. Even if it's something like reusable prompts, they've probably implemented it as a tool. So standard IO for the transport, that just means I'm gonna essentially use console log to communicate back and forth between the agent and the MCP server. And what it does is it actually uses JSON RPC, which is just a way of doing a remote procedure call. It just formats all of the text as these JSON RPC messages. But these ones that are hosted, so the ones I showed like GitHub and MongoDB, those are actual HTTP servers that are hosted by those companies. And you call those just like you would any other API. This is where I think most people get confused about MCP is how does this actually fit into an agent? Who's who, who's in control, what part is implemented where? So I wanted to present this graphic to kind of give you an idea. When we looked at those tool calls in that first demo, what we were assuming is that there's some agent logic. So this is some piece of software that's running on my computer. So maybe this is Claude Code. Claude Code is this AI agent, and there's a bunch of logic internal in that app. And it has some way I can interact with it. I can type into the terminal to give it my prompts, and then I, of course, see the results of that come back. Internally, though, there's a whole bunch of tools that Claude Code can make available to the LLM. So it may have tools to do search and talk to files and read files and create files. And those are all made available internally. So they're described in that API call to the LLM. They're described by the agent. But the agent also implements the client portion of the MCP protocol. So these little kind of curvy arrows up here represent the discovery process. There's really only two calls that an MCP server implements: the discovery and the do a tool call. It's a nice, simple concept. So the first thing the MCP client does is it makes the call to the MCP server and says, hey, what tools do you have available? And the MCP server sends those back. At that point, now the agent code has its list of internal tools and its list of external MCP tools, and it just merges those two together. And that merged list then is what gets sent to the LLM. The LLM has no idea what this tool is or who's doing it. It doesn't care. It just knows that it's a tool it can call. When that response comes back from the LLM containing the tool call, it's up to the agent code to look at that and say, I know how to dispatch this. I'm either going to call my internal code for my internal tool, or I'm going to make the call to the MCP server to execute its external tool. Right? So that's the whole thing. There's really the discovery call and the do it call, and that's all that the MCP server has to implement. So kind of the primary way to do this is through this model context protocol / SDK package. It's an NPM package written in TypeScript. And you implement whatever tools you want to make available inside your MCP server. They do offer this MCP inspector package, which is kind of like a debugger. It's a way of intercepting these messages and being able to examine them so you can do some troubleshooting. So we're going to actually go through creating a little MCP tool. And this MCP server is going to generate mock data. So this is actually something that if you've ever had to build mock data, it's a terrible experience traditionally. In fact, to the point where a lot of people just didn't do it because it took so much time and effort to generate mock data. There were whole apps written specifically to do that job. Large language models will just do it right out of the box. I mean, you can literally go to chatgpt.com and say, I want a bunch of mock data in this format, in this shape, and it'll just spit out a giant JSON array for you. So you don't really need an MCP server to do that, but it's such a nice, easy topic. It's very approachable and understandable. So I think it'll make a good demonstration here on how to build a custom MCP server. So we're going to go through how to connect it, how to set it up and configure it so that our agent knows that it's available and can discover what tools it has. Then we're going to go in and actually build the tools themselves, and then we're going to try it out. So at that point, let's talk about first how we're going to configure it. So that's usually the trickiest part. I'm going to switch over to the code at this point. And look, our Claude code finished up here with all of our refactored code. It's kind of nice. If we look back in here now, we have these nice little repositories and a standard error handling pattern. Much cleaner than before. So that was our autonomous agent was actually doing that job while we were in there watching slides. So the sample code that's in here, if you're doing this on your own computer, it is basically functional. There's enough boilerplate in here that it will run. It just doesn't actually do anything, right? The doing part's not done, but that's the sum total of the code. So you can see there's very little code in here, a couple hundred lines of code, most of that being comments. So the first step is we're going to try and plug this into GitHub Copilot and just verify that we can run it and that it's connected. So I'm going to do this through a project-based technique. So I'm going to come into the .vs Code directory and create an mcp.json file. I'm just going to copy and paste in this configuration and we'll talk through it. So this is a great way, again, in an effort to have consistency. If you want to make a tool available to your entire team, you can define this mcp.json file and make specific tools available to everybody when they clone the repo. So let's talk about transports now. So this is a lot easier when you think about something like an HTTP. So I'm going to actually just switching over my browser here for just a second. There's this really great MCP server called Context7. Context7, you can go to this website, context7.com, has a whole bunch of documentation. So this is one of the ways we combat the knowledge cutoff, because there's nothing more frustrating than getting out-of-date information on your favorite framework. You know, let's say you're a React developer and the last version of React it knows about is React 16 because of the knowledge cutoff date. That's really frustrating. So we can use a tool like Context7 to overcome that knowledge cutoff. And what this does is it's just got a huge database of the documentation for tons and tons of different open source frameworks, tools, packages, whatever. And now I can actually ask my agent to use Context7 to find the latest documentation on X, and it'll go out and search for that product and find the up-to-date documentation. So now it's got better context, because I can tell you that one thing that language models don't do well, they don't handle the concept of time. They handle the idea of patterns. So if that pattern happens to be 4 years old and is woefully out of date, it still knows it and it's still happy to reproduce it. They really seem to struggle with the concept of, oh, I should use the most recent version of whatever. You know, so that's something that you'll find yourself having to sometimes prompt them to do, is make sure you're using X version of this. But MCP can help you overcome that, because now Context7 can go out and find the latest and greatest. So I've put this in here. And now if I look down here in the lower right-hand corner, you can see that it knows now that there's this up-to-date thing. I can click the little refresh button. So should I trust this? That's the huge downside of MCP. You're now accepting context from anybody, right? So consider this like any other piece of information you get on the internet. You have to know who you're asking, and you have to have some reasonable level of trust with that source. If you don't trust it, don't add it as an MCP server. Vet your sources. So if you're talking about something like MongoDB Atlas, that's probably a pretty safe bet. GitHub, same thing. Azure, these are reputable sources that you've already put a reasonable amount of faith in. If it's something other than that, then it's up to you to really vet that source and determine whether or not you have a level of trust enough to connect to their MCP server. So I've connected that. How do I know it's available? So in this little tool down here, when I'm in agent mode, I get this tools thing, and I can look through this list and it'll show me what MCP servers are available. So Context 7 actually only has 2 tools: resolve a library ID and get the library docs. So every time you talk to Context 7, you'll see those tool calls. It'll first make a call to this tool to figure out, based on the text description, to find it, see if they have that library available. And if so, it'll turn around and do the second tool call to fetch the docs. So now that I turn this on, every time I type here into agent mode, I can ask it to go look up the most recent documentation for my favorite project and add that into my context. So why would I not leave all of these checked all the time? If anybody's guessing silently, it's because of the context management, right? We're adding some overhead to every single call that gets made to the LLM in terms of payload size, in terms of tokens, because all of these tool calls get injected into the system prompt. So we're talking about token usage, we're talking about payload size, we're talking about cognitive load for the LLM itself, and we're talking about response time. So, keep in mind that just endlessly adding more and more and more MCP tools might not always be the best idea. Well, let's look at our MCP server. So this was actually, the Context 7 was pretty straightforward. We make an HTTP call to this URL. That's pretty straightforward. But how is it communicating with our mock data source? I didn't go in and start up any node process. I don't have a web server here running locally. This is literally just the chat interface itself. The inner workings of VS Code are executing this JavaScript code in this index file. So if I look down at the bottom, this start server actually just runs an asynchronous process, and it provides console output. It is literally using console.log to send out messages, and those JSON RPC calls are being parsed by the GitHub Copilot code. So when I define this, I define it as a type of standard IO. I have to tell it how to run this code. So I have to tell it, you're going to use Node, and here's the path inside our dev container to that JavaScript file that implements the MCP server. What VS Code does is it actually runs up a separate process inside your computer and then executes this Node process in there and uses that standard IO to talk back and forth. So that's, I think, one of the hardest things to kind of figure out mentally is, where's this code actually running and how? Well, this is just running as yet another process on my computer now. So let's say use mock data to generate 3 users. Let's see if it finds our tool, first of all. Nope. Epic demo fail. It's decided to try and look at these mock data calls. Let's try a different technique. Let's be explicit about using the MCP server. And generally this will, part of the problem here is my developer ability to name things, because we all know that developers are super good at naming things. This idea called mock data server is really kind of hopelessly generic. I could do a much better job of describing what this tool does and a much better job of naming it, and it would probably be better at finding it. Yeah, and it's still not finding it. So part of this might be the model. Let's use a smarter model. I'll actually give it the name of the tool explicitly. You usually don't have to do this, but
sorry, my headphones just died, so I'm switching microphones. Is my audio okay?
Yes.
Okay. So okay. On the third try, third time's the charm, I got it to call. So it's calling the generate users tool using the mock data MCP server. So it's asking me for permission. It's showing me the input. I asked for 3 users. I'm going to click continue. And it says it couldn't be started. That's probably because we haven't implemented anything yet. So bring up some prompts in here in my notes. And let's see what this error is here. Oh, it's because I updated the folder name last night, last minute, to include the word exercise, and I didn't update the README. Shame on me. So this folder name is not correct. Let's see if we find the tool now. So this path has to point to the actual source file, and it was pointed at some directory that doesn't actually exist. And now we're getting another error because I forgot to install the node package. So this is my favorite out of all the things I've shown you today. Parsing really gory error messages, by far my favorite feature of a coding agent. Take really terrible stack traces and post it in, or big long chunks of text out of a terminal log, and it will happily pound right through it, diagnose the problem, and explain what's wrong. So, all right. And you can see here that it figured out the same thing I did by looking at this error message. It said package not found. I hadn't installed the actual SDK package. So the GitHub Copilot actually switched into this directory and ran an npm install for me. So hopefully that's going to take care of it. So let's try reloading one more time and see if that gets us up and running. Okay, so we look again at our tools that are available. There's our generate users. Okay, so this time it was successful. We got it through a little bit of debugging with we said 3. You'll see that the output was actually empty, and that's because nothing's actually implemented yet inside that function. So let's clear our context so that it's not confused about this. Let's put this in here. And if we look at the actual data, that the mock data that's available, we have some first names, last names, email domains, job titles, optionally some addresses. And we just I add a little boilerplate here at the beginning to just read these JSON files in and just make it available as a big chunk of data. So it's picked up here on our tool definition. We had some parameters that were available, whether or not we wanted to include an address and a company. So now it's actually able to build this tool and synthesize some of this information, combine it together and turn it into something more complicated. So it wants to see if this thing will come up and run, and it does, so great. Let's try our tool again. Yeah, that's what I thought. It's not, one of the things that's kind of, I found a little awkward about this is that it's not always easy to force the MCP server to restart, because remember, it's running this as a separate process somewhere. I've found the easiest way to deal with that is just to issue this reload window. It sort of reboots all of Visual Studio Code and forces it to go through and reload everything. Crude, but effective. If in doubt, reboot. It fixes everything. Okay, so now let's see if we can actually use it in here. So now I'm going to make a very natural language kind of call to this. Generate 10 mock users, include company name and address. Interesting. It's called the tool, got the results back, and then actually realized that because it has the source code here, that it didn't implement those parameters. But if we look internally, let's look at what we've actually implemented here while it sort of chugs on that problem for us. We've created a new server. This is just directly out of that SDK, giving it a name. So this is what's going to show up in that tools list. We have a request. We have two request handlers here. One to request the schema for the tools. So this is actually the discovery call. So this is the tool that we've broadcast here that's available. And then there's a tool called request schema. So this is actually the do it call. So that's the only two calls in the whole thing. One describes the tools that are available, and the other describes the tools that are, or accepts the actual call for the tool. So you can see here that we've just got a little switch statement. We've only got one implemented right now, and it returns this generate email function. Okay, let's keep those changes and try one more time. And I don't think it's quite worked because I could see in the parameters it didn't include the Boolean there for include address. So we're still have some bug in here, but I'm sure with a little iteration and probably some better prompts, I could get this to generate. Oh, there you go. Excellent. So the idea of implementing an MCP server is really pretty straightforward. What you do is create this server and then just implement these two calls, the one that describes what tools are available and the one that actually executes the tool. Everything else is completely custom. So imagine being able to connect this to any source you can imagine. And then making that information available. So to give you some concept of how this is used in practice, the agent that I've been building uses a framework called LangGraph. And LangGraph is just a way of building, it's a framework that lets you build agents. They've gone through quite a few iterations on the way LangGraph works, and their documentation is on their website is kind of spotty. You know, some of it's out of date, some of it's gone through multiple different versions. So I connect context 7, and anytime I'm going to do a LangGraph specific prompt, I include check with context 7 to get the latest documentation for LangGraph. So I find that the results that are generated are much more accurate because it has this current information available on the docs for LangGraph. Then the platform that I use for auditing on that is called Langsmith. They also provide that platform. That's a really extensive logging platform for LangGraph agents. So it contains a really detailed trace of exactly what happened. It shows all of those messages that we looked at in that original API call, all of the context that is built up and the memory that's built up during the conversation. It shows exactly what was sent in the payload to the LLM, and then it shows the response that comes back. So it's got this huge amount of information about how the agent's working. They provide an MCP tool that allows me to just send a trace. So I've literally built a feature into the UI, into the chat interface, that has a little copy to clipboard button with the trace ID. And in addition to that, this agent that I'm working on helps manage backlog items, I store an index of all the backlog items in a MongoDB database. And MongoDB, of course, has their tool available. And their tools will do things like query a specific collection, add items, remove items. It can do any sort of operations you let it inside the data. When I combine all those together, I can implement a new feature in that agent, tell it talk to MCP or talk to MCP for context 7 so that it can gather documentation.
Ryan, you're muted.
Yep, sorry. It's the one time during the day that somebody's coming to pick up my daughter and the doorbell rings and the dogs go insane right in the middle of the demo.
Of course.
So I get these things generated using the latest documentation. Then I run the agent and inevitably something doesn't work. Now, when it doesn't work right on the first try, it's usually the result of I put in this prompt and it didn't work right. And why is that? So I can actually go right into my Claude code, paste in that trace ID, have it load the entire history of that call, that interaction with the LLM. It processes all of that information. And then I can say, well, review this trace against the data that was generated in the database. And all of this now is automated and coordinated through the LLM. It'll actually load the entire diagnostics of the thing, look at the information that was sent to the LLM, look at the response that came back from the LLM, compare that against what's in MongoDB, and then generate a response back to me that says, I think you should change this in your prompt because you would get a better result. Now imagine doing all of that manually. That's, for me, that's one of the reasons that I wanted to really hit this idea of MCP servers pretty hard, because I think it's the thing that unlocks the greatest amount of potential in these coding agents out of everything else that's out there. It's this idea of being able to tie in all these external tools and then use an LLM as the central mechanism to digest all that information, analyze it, and then return some sort of coherent result to you. So that's something that if you haven't done this and all you've done is just use the agent directly to do code, look into MCP servers that can fetch additional information and augment that context. And you'll find that what you're getting out of the tool is substantially better than what you did before. Okay, so hopefully that's exposed you to all of the concepts that I think are kind of fundamental in using LLMs as a developer. The idea of improving your prompting, understanding how agents really work, because I think when you understand how the tool works, you can get a better result out of it. And then ultimately tying in those external tools through MCP is sort of the frosting on the cake. That's what really brings everything together and turns it into a super powerful tool. So I hope you all got something out of that. I'm quite happy to hang out here and answer questions, have a chat about projects you may be working on or interesting things that you want to chat about. But thank you all for coming.
Get me to the session 5, please.
On it.
All right. We're gonna bring this home. And there's a whole section 4 in there that kind of talks about production related stuff. We just don't have enough time to get to it, but there's still in the repo, you'll have the slides and you'll have access to all the different bits there, and you can play around with it. But I think that's going to be might be one of the topics in our next course that we're going to create. So for what it's worth, there it is. So First, I'll pause and ask if there are any other questions.
I've got a question for you. So after hearing your talk about MCP, is there still any good use case for RAG, or is MCP a better solution 99% of the time?
It depends on what retrieval you need to do. So let's take the example of that context 7 server. That is RAG. That's a textbook example of RAG, but it's RAG that I didn't have to write. So that's the best kind of RAG, is the one that you don't have to actually build. So it's not really that it replaces RAG. A lot of time, there are quite a lot of MCP servers that essentially implement RAG. It's just things that you can plug in immediately versus something you have to write yourself.
Okay, that makes sense.
It's just that the context 7 is a really simple tool. There's 2 queries. Give me a library ID, give me the docs for that library. So that's actually a very simple MCP server. Some of the MCP servers get significantly more involved. There's a neat one for Azure, and it will actually, imagine you're a DevOps engineer and you're working on provisioning resources in Azure. As you're building, say you're building bicep scripts to do all this automated provisioning, the ability to talk to the agent and say, hey, can you look out there in my cloud and tell me what resources I already have, and then tell me if I have a bicep script that automates the implementation of that. Imagine not having to do all of that research manually. That's where you can really leverage some serious power out of MCP.
All right, any other questions?
I'd be curious, it does sound like that's kind of the unlimited power at your fingertips method. What do you suggest for those interested in taking that to the next level? I mean, just play around with it? Are there forums, or how do you suggest we get more exposure to that?
Sort of depends on your learning style. If I'd say in most cases, developers tend to learn by doing. So, I like experimenting with them. Those in the notes, there's that registry. That's a great place to start, because just seeing what kinds of things are available is kind of an interesting place to start. Sometimes that triggers something you think, oh yeah, I could connect to this logging platform that we use, or this analytics platform that we use, and I could automatically pull in data from that as part of my conversation. Some of it is even thinking about, I've written several little MCP servers that connect to internal data sources. So things that historically I would have had to do a lot of copy and paste. No more copy paste. You can see that with an agent, you can pound out an MCP server in probably 30 or 40 minutes realistically, and connect to some sort of internal information. So there's just a huge number of things out there.
Thanks.
All right, any others?
I had this all typed up, but I was waiting for the right time, so I'll just leave it there and you can read it.
Yeah, fair enough. So this is all about having the question is, there's a gap between, hey, these models hallucinate, you need to be really careful, and oh, by the way, there's an agent that can pick up an issue, do the entire thing, and create a PR. So it's all about the trust level that you have, and about the amount of time and effort you put into the review. So I thought a lot about this as I was prepping the course, and particularly with autonomous agents. And my thought here is, let's look at the reality of where junior and even intermediate level devs are. If you've ever spent, like I have, a significant amount of time reviewing PRs from entry level, they're bad. They're bad a lot. And that's humans doing it. So if an agent does something that's not quite correct, I don't feel like I'm in any worse position than I was before. But I still have to be careful about reviewing. I learn over time how much trust I have in a particular developer, and that influences how rigorous I am in the code review. I think the same thing holds true here. The other thing is doing your due diligence up front in things like, if you're doing it interactively, make sure that your prompt is solid before you start. It's worth spending 5 minutes writing a really detailed prompt that has your requirements clearly spelled out, because if unless you're doing something kind of trivial like we did during the class, you could get away with iterating 3 or 4 times. If you're doing something more substantial that's on a larger scale, it's worth spending those minutes up front on the prompt, because that saves you having to go through 2 and 3 iterations on it. The same holds true when you write a GitHub issue and you're going to try and assign it to the GitHub coding agent. Take some time and really, put on your Scrum Master hat, do what Brian does well, and write a decent story. When you do that, you get value out of that now, because that the PR is much more likely to be correct. So I think it's a combination of, over time, learning how much you trust, learning when you need to really heavily review versus scanning it, and then it pays to do more prep work up front. We're finding, as we use this process internally, that the documentation phase historically was skipped. Honestly, nobody took the time to really write a formal requirements document. It is well worth your time to do that. Let's say you're working at something little bigger scale. We're not just going to go in and refactor a function or add an API endpoint. Let's say that we're going to use AI to implement an entire feature. I would spend several hours vibing back and forth with an algorithm to help me really refine my requirements document and make sure that my requirements were as complete as I could come up with, and very detailed and very specific. Then I would go through that phase of building the implementation plan and breaking that down into some manageable chunks. And then each one of those chunks, I would go into a vibing session and construct a really decent prompt to do that section. And so it's about decomposing this big problem down into smaller, manageable pieces. And so then the manageable piece becomes easier to review, and that review process becomes more accurate, because I'm not trying to review something that touched 80 files and wrote 4,000 lines of code. I'm trying to do something much more manageable, and that helps me catch those errors early rather than letting them go through.
All right. Any last questions? Thank you. And Ryan, if you'd go on to the next, and let's fire that video. I'd like to introduce you to Unify by Intertech, something that Ryan and I are both working on. You just have a different idea. Thanks. Well, that didn't go like I planned, but let's go to the next slide, which I have just to explain what you should have seen on the video. Anyway, so Ryan and I are working on a new offering that Unify, Intertech, and mixed them together. Unify by Intertech, and it's really about a, a more effective way to do software development, kind of leveraging the lessons that we kind of went through in this course. But what we're working on is building that army of agents that can be used to help accelerate any kind of project that you might have. And so we'd like to invite anybody that's interested. In the feedback form here, there's the ability to identify if you'd like to learn more about that, and if we could help you in any way, put this stuff in motion for you. We've got an army of agents to help. And so if you go to the next slide, please. To the point, Ryan and I both are here to help. And so we've got the contact information. You can find us both on LinkedIn, and our email addresses are there. And you have them in the meeting invites as well. Next slide. Finally, we'd really love to get your feedback. This was the first time we've offered this course, and we'd like to ask for your assistance to make it better. And so you can use a QR code if you want to do it on your phone, or I put the link here in the meeting chat. And if you wouldn't mind taking a few minutes, it's not a very long survey, but it would give us some directional feedback so that we could improve it for the next group of students, which, by the way, we're planning on in October. We haven't set a date yet. So if you have colleagues or friends, please send them our way. We'd love to get them involved. We got a short waiting list because we did end up closing the registration a little early on this one, so that we could get a head start on the next course. So with that, one last slide. Thank you very much. And Ryan and I will hang out here for a little while. And if you've finished that feedback form, please feel free to hang around if you want to. But the class, as we had intended it, is all finished. So thanks again for coming, and I hope you got what you came for. Have a great day.
So, Brian, I have a question. I'm new to this and processing a lot of it, but it seems like most of what we covered was using an agent to assist us in our internal coding and development and operations. As we would think about including an agent in a product that would then be, client facing. Do you guys offer any classes or resources as an introduction to that?
You're muted, Brent.
Thank you. So on the feedback form, I left room for that. Are there any other courses that we should offer? And we would love to, if you wouldn't mind including that there. Sure. I think that's an excellent idea.
Yeah, building your own agents is a super hot area of development right now. Tons of activity, tons of research in that area. It's challenging, but I find it to be super interesting. I've really enjoyed the process of building agents.
Great. Happy to do that. Thanks.
Thanks a lot. There we go. I think it's just us kids now.
I'm gonna stop the recording, probably.
Oh, sure. Good idea. Thank you.